A parabola is the collection of points P in the plane that are the same distance from the fixed point F as they are from the fixed line D. So let me go over this definition. Collection of points P. The collection of points are the parabola itself. And what this is saying is that this collection of points, which is the parabola, in order for it to be a parabola, they have to have the same distance from the fixed point F, which is called the focus, which is here. They have to be the same distance to the focus as they are to the fixed line D, which is here. And this is called the directrix. So if I have a collection of points, and they all have the same distance to the focus as they have to the directrix, then by definition it is a parabola. The only other point of note on here besides the focus and the directrix is the vertex, which is the highest or lowest point on the parabola, or in this case, it is the most sideways point. So now that I have the definition of a parabola, what I'm going to do is come up with a way of getting the equation of a parabola. And normally accompanying every algebra book, there is a big chart that gives the equations depending on a couple of things. The equations will vary depending on the direction of the parabola. So it could be opening up or down or right or left. And if it's opening up, down, left, or right, it will be symmetric with different axes. And in this case, it's symmetric with the x-axis. So it can open left or right, and that will change the formula. If it were symmetric with the y-axis and it was pointed up, then that would be a different formula. And then, of course, if it was pointed down but still symmetric with the y-axis, then that would be another formula. So there are 4 different formulas. They look very similar, and it just depends on if it's up, down, left, or right. But as usual, it's not really a smart idea to memorize this, so I'm going to go ahead and show how I get these different formulas. And then from there, they'll be extremely easy to remember. So the way we get this formula is we bring up the definition of a parabola. Now mathematically, this statement can be written as the distance from the focus to a point must be equal to the distance from the point to the directrix. And that is what this here says. I've got a collection of points, x, y. I have one drawn out here. This distance must be equal to this distance for all of them. So this distance equal to this distance. And in this case, well, in all cases, the easiest way to look for equal lengths is to look at the vertex to the focus and the vertex to the directrix. Now this is how I'm going to get the equation. Since the vertex is the highest or most sideways point, I'm going to say that this distance from the vertex to the focus is A. So if the distance between the vertex and the focus is A, then the distance from the vertex to the directrix must also be A, as far as pure distance is concerned. So from that, I'm going to be able to get my formula. So the definition, the distance the point to the focus is equal to the distance from the point to the directrix. And I'm just going to start out with the vertex being at 0, 0, and then I will go ahead and change it to an ambiguous vertex, or just any vertex. So for right now, I'm going to say the vertex is 0, 0. If the vertex is 0, 0, I'm going to need two other pieces of information. I'm going to need to know where the directrix is, and I'm going to need to know where the focus is. So if I have my vertex at 0, 0, and the vertex is a units away from the focus, and I'm going to do this example for a parabola that opens to the right and is symmetrical with the x-axis, and then I will show how to get the other ones. But for now, I'm just going to stick with this particular parabola. If I have a vertex at 0, 0, and it opens to the right, that means that the focus is going to be a units to the right on the x-axis. So the focus is a 0. Now the directrix is going to be an equal distance away from the vertex as it is to the focus. Now equal distance-wise, but in the coordinate plane that would make it a negative number, so it'll be a units backwards. And this is going to be a line, so the directrix is going to be located at x is equal to minus a. That is what this line is equal to. X is equal to minus a. No matter what y value, x will always be equal to minus a. So I have my three pieces of information. Now all I need to do is take the distance between the point and the focus, and the point and the directrix. And then from there I'll be able to get a formula. So I'll need to use the distance formula. I'll write it out here very quickly. So I'm going to find the distance between the vertex and the focus. So my point, I forgot to put my ambiguous point, x, y. So the distance between the point and the focus, x minus a squared plus y minus 0 squared. This is all squared. And this is equal to the distance from the vertex to the directrix. Now the directrix is just a line, and it has a value of minus a no matter what the y value, so I don't really need to use the distance formula. I can just do it the good old-fashioned way by just doing x2 minus x1, the absolute value of that. So this is equal to the absolute value of the point x minus the value of the directrix, which is always going to be minus a. So this will turn into a plus, and it's an absolute value. Now I'm going to square both sides. I just got rid of the absolute value signs because when I square this, it's always going to be a positive number. Now I just continue along. And subtract out like terms, so these will cancel, and a squared will cancel, and then I can add to ax to both sides, and this will give me y squared is equal to 4ax. Now this is just for a parabola that is symmetrical with the x-axis and opens to the right, so like this, and assuming that the vertex is 0, 0. If I want an equation for something with a different vertex, with an ambiguous vertex, so vertex hk, Then all I have to do is just subtract the vertex values from the y and x. So this would be y minus k x minus h. And this is for a parabola that is symmetrical with the x-axis. I'll just draw it. I'm just going to write it out. So this is for a parabola that looks like this. Now obviously parabolas can open up, down, and to the left as well. But let me just confirm that I got it right. So I have a vertex of hk, focus a0, directrix x is equal to minus a, and the equation is the same one that I got. Symmetrical with the x-axis, opens to the right. Now, what about for the case that the parabola opens to the left? Well, it's a really simple fix. Instead of the focus being a positive x value, let's take it back to the situation where I had it as the origin, and it opened to the left. That means the focus is going to be over here, and it's going to be a negative value. And if the focus is a negative value, the directrix is the same distance over here, but it's going to be the opposite sign because it's going the opposite direction. So the directrix is going to change to a positive value. So all that happens is that the a changes sign. So for one that opens to the left, it will be the exact same formula. And there's no need for me to rework the entire thing, because it would be exactly the same way. The only difference being that the a would have a different sign. So all I do is, wherever there's an a in this formula, is I change the sign. So this would be minus 4a x minus h. And if I go back over here to my chart, I can see that is exactly what I did. I changed the a to a minus a, the directrix changed to a positive a, and then the formula, all that happened was this minus sign switched. Now, what about the situation where, circle this, where I have a parabola that is symmetrical with the y-axis and opens upward? Well, it should be pretty apparent what I have to do now. Since this parabola now opens upward, the focus is going to be a positive y value. So instead of the focus being a0, it's going to be 0a. And the directrix, instead of being a constant x value, it's going to be a constant y value. It'll be y is equal to minus a, since it'll be in the opposite direction as the focus. So all that happens is that the x and y values get switched around. Instead of here having an x minus a, and a y minus 0, I'm going to have an x minus 0 and a y minus a. So what will happen is that the x, and of course the y plus a. So what will happen is basically the x and y's will change places. So I'll have, well, I don't have to write it this way. I'll just change it the other way around. X minus h squared is equal to 4a y minus k. If I go over here to the chart, you can see that's exactly what I did. It's centered at hk. The focus, instead of being a0, is now 0a, because it will be a positive y value. And the directrix, as a result, will be a negative a value. And here is the formula, and I can see that I got it correct. And for the last formula, it's just the same procedure as I did for the other one the other parabola that opened to the left instead. When it opens down, all that's going to change is the location of the focus, it will be a negative number instead. So all that happens is I change my a value. So minus 4a y minus k. So this may seem like a lot of work, but I personally would recommend this method instead of memorizing this whole table, because it's very easy to get confused with the numbers and the a0 and 0. If you're not thinking about it logically the way you would approaching a formula, I think it's very easy to make a mistake. All that really needs to be remembered is this: the distance between a point and the focus is equal to the distance between the point and the directrix. And if one can simply remember what the focus and directrix are, then it's a very simple problem using the distance formula. And then the other ones can be logically deduced very easily. So I would definitely recommend just to remember this. This is all that needs to be remembered. The distance between F and P is equal to the distance between P and D.